Today we're talking about solving two-step equations. Now when we're solving any equation, we have two goals. And the first goal is to isolate the variable. And we've talked about how this means I want to get x by itself. I want x to be the only thing on, in this case, the left side. And I want to know what value would make this statement true. What value of x would make this statement true if 3 times x minus 5 is equal to negative 14. And the other goal was to balance the scale. By balance the scale, I mean we have to do the same thing to both sides. If I add 3 to the left, I have to add 3 to the right. That will keep my scale balanced. That will keep each side equal. Because remember, this is an equation, which is saying that this side is equal to this side. Or 3 times x minus 5 is equal to 14. So I want to do the same thing to each side to keep those balanced. When I've got a two-step equation, the first thing that I want to do is I want to get rid of that addition or subtraction. So if you see on the left side, I have a minus 5. The opposite of subtracting or minus 5 is adding 5. If I add 5 to the left, I have to do the same thing to the right. I still have that 3 times x or 3x. Negative 5 plus 5 is 0, and plus 0 is nothing. And that's going to equal to negative 14 plus 5 is negative 9. Now I've got 3 times x is equal to negative 9. And the second thing I want to do in a two-step equation is undo that multiplication or division. So the opposite of times 3 is going to be divided by 3. And I need to do that on both sides. Again, I'm balancing the scale. 3 divided by 3 leaves us with just 1. 1 times x is just x, so I'm left with x is equal to, I know that a negative divided by a positive is going to be a negative, and I know that 9 divided by 3 is 3. Negative 9 divided by 3 is negative 3. So in this case, x is equal to negative 3, which means that if I go back up, I can check my work by putting this negative 3 in for x, substituting x with negative 3. If I check that, I've got 3 times negative 3 minus 5. Does that equal negative 14? Well, 3 times negative 3 is negative 9, and negative 9 minus 5 is negative 14. I could also have a two-step equation that involves division instead of multiplication. And in that case, once we get to our undoing multiplication or division, we're going to multiply to undo that division. But first of all, I have this plus 6, and I know that the opposite of plus 6 is minus 6. And if I subtract 6 from the left, I have to do that on the right. Now I have x divided by 4. A positive 6 minus 6 is 0. And negative 18, take away another 6, or minus 6, is negative 24. Now I'm left with x divided by 4 is equal to negative 24. I'm going to multiply by 4. And if I multiply by 4 on the left, I have to do the same thing on the right to keep my scale or keep those sides balanced. And I'm writing it this way as a fraction, 4 over 1. Or 4 wholes, so you can see how this will work because I've got 4x over 4. And just like in that first example, 4 divided by 4 is 1, so that is just 1x is equal to negative 24 times 4. I know a negative times a positive will give me a negative. 24 times 4 is 96, so I'm left with x is equal to negative 96. If I wanted to go back up, I could substitute this negative 96 in for x. Negative 96 divided by 4 is negative 24, plus 6 is negative 18.